Hello, in this video we will continue talking about nonparametric statistics and a test called signed rank test. Here we use examples for paired observations. We know in traditional statistics, most of the tests like a t-test, a chi-square test, or f-test have assumptions that the data coming from normally distributed distribution, at least approximately normal distribution. But sometimes these assumptions cannot be met, and the data maybe have very skewed or very far from the normal distribution. So one kind of alternative is to use nonparametric statistics. So these kinds of tests called distribution-free tests. We do not assume any probability distributions for these data. So the signed rank test is to test the hypothesis of the median of the data equals one specified value. So here we subtract all the data from this specified value. Then we rank with the absolute value, no matter it's positive or negative, the value. So we rank these absolute values, and next we take two parts of this sum of values, sum of ranks, which come from positive value or from negative value. If the difference, if the smaller of this one rank, of these two rank, the smallest of these two rank is very small or over the critical value from signed rank tests, so we will reject. In the case, for example, if this is the null hypothesis, mu equals this specified value. So this hypothesis H0 can be rejected if this positive side of the rank is very small, it is too small. So we will favor that this real median value less than this specified value. On the other hand, we can in favor alternative that this real population median value larger than this specified value if the negative side of the rank is too small. And there's a table that we can use for observations and for significance level 0.05 and a one-side or two-side test. This is the critical value. So if the smaller part of the rank less than this critical value, then we will reject the null hypothesis and in favor of alternative hypothesis. In the case of the paired observations, we want to test if the difference of paired observations equal to this specified value. And similar as before, we can use the difference of these paired observations as the population mu from the previous page we want to test. Then next procedures will be the same. So next we will use one example to show more clearly how to carry out this signed rank test for paired observations. So it is claimed that a college senior can increase his or her score in the major field area of the graduate record examination by at least 50 points if he or she is provided with the same sample problems in advance. To test this claim, 20 college seniors are divided into 10 pairs, such that the students in each matched pair have almost the same overall grade point averages for their first 3 years in college. Then the sample problems and answers are provided at random to one member of each pair 1 week prior to the examination, and examination scores are given in the table. So this table lists 20 observations and 10 of them with sample problems, and another 10 without sample problems. So this is the result of the final grade score. So the question is, test the null hypothesis at the 0.05 level of significance that sample problems increase scores by 50 points against the alternative hypothesis that the increase is less than 50 points. So here we let the mu1 hat and the mu2 hat represent the median scores of all students taking the test in question with and without sample problems. Then the null hypothesis is mu1 hat minus mu2 hat equals 50, and alternative hypothesis is mu1 hat minus mu2 hat less than 50. And the significance level is 0.05. Then first we check from the table, because n is 10 observation pairs, so n here is 10, and the standard rank test shows the critical region to be the positive ranking total will less than 11. So if the positive rank sum less than equal to 11, then we will reject this hypothesis and in favor of this alternative hypothesis that the increase score less than 50. So next we compute the score difference first. So here is the DI is the difference between each pair. Then further we minus each pair difference with this specified value 50. So here is, for example, the first difference pair is 22, then minus 50 is minus 28, and so on. So we get this value, and there is a ranking because these two has the same absolute value, so we use average of their ranking here. So next we sum all ranking values from positive side. So here is positive, and this is positive. So 3 positive ranking is this one, and this one. So which means total ranking from positive side is 10.5. Because this 10.5 is exactly less than 11, which is the critical value. So here we make a decision that reject H0 and conclude that sample problems do not on average increase one's graduate record score by as much as 50 points. Thanks for watching.